Good morning to everyone.
Morning, ma'am.
Good morning, ma'am.
Good morning, ma'am. Good morning, ma'am.
Good morning, ma'am.
Yes, good morning to all. In the previous term, we have learnt about the univariate and multivariate image statistics. In the univariate, you have learnt about different statistical terms that you may already aware about, which were for the central tendency, you have learnt about the mode, mean, median. Thereafter, means we have started with the histogram basically, which is a graph plotted between the brightness value, digital number, versus frequency of occurrence or number of counts. This is what we have started from. And thereafter, we have learned about the normal histogram, in which we have learned different terms, which is about the measuring the central tendency through mode, mean, median. Thereafter, to learn about the dispersion from the central value, we have two terms, variance and standard deviation. Then there is another called range, which is max minus min. These were the univariate statistics. Along with that one, there were two more properties to measure the asymmetry of the histogram, which were skewness and kurtosis. Okay, so you all must remember the formula of all these things, and these are the terms that we are going to use frequently throughout this SIP course. Thereafter, we have learnt about multivariate image statistics. In multivariate image statistics, when we consider more than two bands, more than one band, in multispectral images, there will be more than one band, and usually when you see the image, it will be consist of more than one band. That's why it is necessary to learn about the multivariate image statistics also. Just like in univariate statistics, for against the one band, there is a histogram. It can be plotted only for one band. But when we have more than one band, in that case, instead of plotting the histogram, what we plot? We plot scatter plot. Okay. We draw scatter plot in which two different bands are taken on x and y axis and a dot is placed. So it will not tell you about the frequency of occurrence, but it will tell at least one pixel will have that value. Through scatter plot, you have learned regarding this covariance and correlation. Okay, when we talk about more than one band, in that case, what is the relationship between the two bands? Which two bands are positively related? Which are negatively related? Which are independent to each other? This is what we have learned in that one. So we have learned about the variance, covariance, their formula, and how they will appear on a scatter plot. In today's turn, we are going to start with a numerical. Okay. Yes. Right now on the screen, you can find this numerical. This is, if you see this one, it is showing the pixels. There are total 5 pixels and there are 4 band, green, red, near infrared, again in near infrared. I think so it should be blue, green, red, near infrared. Doesn't matter, there are 4 bands. Okay. From this one, you need to compute two values. First one is variance covariance matrix and second one is the correlation matrix. The formula is already written over here. First one is showing the covariance formula and second one is showing the correlation formula. Okay, so you need to quickly find out the values of the covariance and correlation, and thereafter you need to draw the variance covariance matrix that we have learned in the last term. Okay, so start doing this. If you have any doubt, you can ask. Please confirm whether the screen is visible or not.
Yes, ma'am, visual.
Okay.
हेलो मैम।
यस।
मैम जो वेरिएबल है यहाँ पे बैंड 1 बैंड 2 दो एक टाइम पे लेंगे ना?
हाँ, सबके बीच में आपको निकालना पड़ेगा।
मैम चारों को एक साथ?
नहीं, कोवेरियंस तो 2 के बीच में निकलता है ना, 4 के बीच में नहीं निकलता।
तो मैम वही पूछ रहे थे कि बैंड 1 और बैंड 2 को एक बार में लेके सॉल्व करेंगे फिर अलग अलग ऐसे?
पूरा 2 का पूरा जितने भी परम्यूटेशन कॉम्बिनेशन आपके बनते हैं 1 2 1 3 1 4 देन 2 3 2 4 देन फाइनली 3 4।
थैंक यू मैम।
So variance covariance matrix must have been computed. Is there any problem in variance covariance matrix?
No, ma'am, not yet. It is taking too much of time, ma'am. It is very long to do by simply hand, ma'am.
Okay. This one is the final answer. This is computed. This one is the variance covariance matrix and this one is the correlation matrix. Check your answers. Check the solution and I will move on to the today's topic. Okay. Those who have not yet completed this question, solve the question later on. But right now check few of the answers, whether the variance covariance values of few bands that you have computed, check whether they are coming the same or not.
Ma'am, between 1 and 2, my one is coming correct, but my between 1 and 3, I'm not getting the right answer, ma'am. I'm getting 543.75.
Okay. Anybody else? Anybody else has computed the variance covariance between band 1 and 3? Sumit, your value is coming as 575.
No, ma'am, I was getting 543.75.
Okay, I will do one thing. I will solve this question by myself and later on confirm. Meanwhile, meanwhile, other students also solve this question and check whether the answers are matching or not. Okay, I will check it later on if there is any confusion. One of the confusion is raised between band 1 and 3. I will check it. And all of the students also need to compute this variance covariance matrix and later on correlation matrix from this one. I will tell the solution between 1 and 3 later on, okay, because it will take time. Now, coming to the next one, and we are starting with the image pre-processing step. Okay, any of the image processing, if you see, there are certain typical steps in image processing. It starts with the image rectification and restoration, which we simply say image pre-processing. Any type of error which is present in the data set is removed in the very first step of pre-processing. Since it is performed before any type of analysis, any type of manipulation is done, therefore it is termed as pre-processing. There are several ways through which we can perform the rectification in the image that we are going to discuss today. Once the pre-processing on the image is done, the next step is image enhancement. Okay. In image enhancement, basically we try to improve the visual interpretability of any image. There are several techniques for this purpose. We will see them when we cover this topic of enhancement. But by using some techniques like contrast enhancement, multi-image manipulation, we improve the image interpretability, better readiness of any of the image. The visual distinctions of the features get improved by the enhancement process. Once the enhancement is done, the next step is image classification. Okay. What happens in classification when you see any image, like if I open one of the image, this one. This one is the image of Prayagraj. Okay. If you see this image, you need to interpret this image. Like the blue color thing that you are seeing on the screen is Ganga and Yamuna River. Then you can see some green portions, some red color portions since it is false color composite. So this pink and red is showing the vegetation. Then you can see some other things which are present over here. Then you can see some blue color thing which are urban settlement over here. I have placed my cursor at this place. So you can see the urban settlement over here. What is going on? I am performing the image interpretation right now because nothing is mentioned on the image. As we have learned in the previous semester about the difference between the map and the image, in the map, everything is well annotated. Everything is written, everything is labeled over there. But when you see the image, right now I have opened the image, you need to interpret this image. Nothing is written over here, isn't it? So what happens once we done the image enhancement, it is followed by the image classification. In classification, whatever in visual interpretation that we are doing, the image get converted, the multispectral image get converted into the classified map or classified image, okay, in which we are not going to perform the interpretation, but there will be certain land cover values which is associated with every pixel. Like this one is forest, this one is river, this one is agriculture, this one is open land, like this way. So after the enhancement, the next step is image classification, where every pixel is assigned certain land use land cover value. The next of the process, it depends whatever is the requirement, like data merging and GIS integration. Many times different types of data get integrated. There are different types of data, like there can be some map data, there can be some image data, there can be some sensor data. So many data are available. If required, we can merge those data, we can integrate the image analysis with the GIS. If hyperspectral is required, then that could be done. And the last step consists of image transmission and compression. Okay. So when we need to distribute that image over the internet to different people, in that case, we cannot send the image as it is because the size is very large. So how the compression is taking place, how it is getting transmitted, it comes in the next step. During this course, the focus will be on step 1, step 2, step 3, step 5. Okay, these are the steps that we are concentrating on this subject in the satellite image processing. So I'm starting with the very first one, which is the image rectification and restoration or image pre-processing. Now, coming to the pre-processing thing, the very first question is, why do we say pre-processing? Because this step is done before any other step. Before you perform enhancement or classification, whatever you want to do, you can do it, but it comes later on. The very first step will be rectification and restoration. Whatever error is present in the data, whatever distortion is present in the data need to be removed first. That's why we are performing this step. When the image get transmitted or when it is get distributed by any of the agency, like I will take the example of Earth Explorer, you can download the Landsat data from there. Okay? But before getting that data from this website, there is some processing which is already done at the ground stations. You will not get the raw data, whatever data is received from the satellite sensors, we do not get that data. Some amount of processing is already done at the ground stations, only thereafter we get the data set. Isn't it? If you see, um, this one. Okay. So if you see this one, see how the data, how we get the data, how we get the image. First, the remote sensing is done. There will be source of energy which is propagated through the atmosphere. Then there will be three things that can happen. It can be either reflected or absorbed or transmitted. So there will be retransmission through the atmosphere. Then there will be sensing systems. So whether there is a satellite remote sensing or airborne remote sensing, whatever is done, the sensing is done, and thereafter the sensing products are developed over here. Okay. So when this sensing products are developed, whether it is distributed through CD by any pictorial from whatever form, we are distributing the data before sending the data to the people, and they would perform the interpretation. They will create different type of information product over here by performing the data analysis. During the data, once the data acquisition is done and data get distributed to the people, at this step there will be some processing which is done by the providing agency. Got it? So you are not getting exactly raw data. Some of the pre-processing is already done at the ground stations. When we receive the data, it still consists of the errors. There are so many. If you read the books, whether you are reading the Jensen, whether you are reading the Mather, whatever book you are reading, if you learn about the pre-processing, there are so many different operations that are present through which we can perform the pre-processing. Are we going to perform all the operations on our image? The answer is no. We are not going to perform all the operations when we are doing any type of analysis. Like, suppose you have some image, okay? From that image, you need to identify whether the vegetation is present in that scene or not, okay? Whether the geometric correction is required in such type of image, the answer is no, because we are not concerned with the location. The question is mere the presence or absence of the vegetation, whether the vegetation is present at that place or not. Even if the image is not geographically corrected, the position is not correct, even then it doesn't matter, because the position of the vegetation is not a concern. It's just presence or absence is concern. In this type of problem, the geometric correction may not be required. But suppose there is another problem. We need to give the distribution of vegetation in the study area, or in a given scene, we need to give the distribution of vegetation. Once we are telling the distribution of vegetation, the location of vegetation, in that case, the position become important. Now, the same geometric correction which was earlier not required, which was earlier not necessary, now in this case it is mandatory to perform the geometric correction on the data set. Only then the correct position of the vegetation will come. Okay, so you need to study, you need to identify what type of application you are using, what type of use of image is required. In that, on the basis of that one, we decide which type of correction is required, which type of correction is not required. All types of corrections are not done. Even pre-processing is quite time-taking process. So we do not perform all the operations. We need to check what type of error is present, whether it is possible to carry out the operations without the correction or not. What is the future applicability of the products that we are developing? On the basis of that one, the corrections are decided. Now coming to the different types of corrections, we will take on one by one, and starting with the cosmetic corrections. First, we will learn about the problem, the error, and then we will learn about the solution. Coming to the very first error, coming to the first one, which is the cosmetic correction, write down in your copy. Write down in your copy. Write down the heading. Image rectification and restoration, or image pre-processing. Okay, write the heading image rectification and restoration or pre-processing. First one is cosmetic correction. First one. So okay, so the first one is the cosmetic correction. In the cosmetic correction, there are the different types of errors which are mentioned over here. First one is the periodic or random missing line error. Write it down. There are three errors that we are going to learn under the cosmetic correction. First one is the periodic or random missing line error. This one is the line dropout error. Second one is line stripping error. And third one is the random or spike noise. So these are the three different errors that comes under the cosmetic errors. How this cosmetic error arises, okay? Coming to the term cosmetic, what is the meaning of cosmetic? Anything that appears, visibly appears on the screen, that type of error comes under the cosmetic error, okay? The very first one, which is the line dropout error, what happens in the line dropout? I will show you this error on the example. Right now on the screen, I have opened the Earth Explorer website. Okay, see this one. This one is the Prayagraj area. This one is the Landsat ETM plus data. Okay, you can see the data set over here, Landsat 7 ETM plus collection 1, level 1. This one is the data set. And right now on the screen, you can find it very clearly. What is happening? See. Just see the screen carefully so that you yourself be able to identify the array that is coming over here. I'm just zooming in. You need to wait a little bit because it will take some time. Yes. Is it clear to everyone what is happening? See this. Black color lines, completely black color wedged line are appearing on this one. It means whatever is present on the ground, like as you can see over here, a river is flowing. So in the image, at most of the places, this river is appearing, but wherever this black line is going on, the river is not appearing at that place. Okay. So what is this error? This is called line dropout error. Now, before coming into the detail of this one, first we need to learn about the mechanism of Landsat. Okay, how Landsat sensors work. Anybody could explain about the working mechanism of Landsat? You have already learned because in the first, second, even up to the third lecture, we were discussing about all this working thing. Anyone? How the Landsat works? Yes, Yashovardhan? Yashovardhan, are you there?
Yes, ma'am.
Yes. How Landsat sensors work?
Ma'am, they have optimal ground resolution and they can efficiently track land use and document land change. Uh,
No, what you are saying? L- What is the working mechanism? What is the working mechanism of the sensor? ये सेंसर काम कैसे करता है? लैंड यूज लैंड कवर है तो प्रोडक्ट से आप निकालेंगे, आपके पास इमेज आ गई, देन आप इस इंफॉर्मेशन को उससे इंटरप्रेट करेंगे. यहाँ क्वेश्चन ये नहीं है कि प्रोडक्ट कैसा बन रहा है, यहाँ ये क्वेश्चन हो रहा है इमेज एक्विजिशन कैसे हो रहा है, सेंसर क्या कर रहा है जिससे इमेज एक्वायर हो रही है. Okay, next one, Vibham. Vibham Nayak?
Yes, ma'am.
Yeah.
Ma'am, Landsat satellites, they are attached with passive sensors. Then passive sensors, they detect the radiation which is emitted from the Earth in a different bands, ma'am.
Are you done?
Yes, ma'am. So
Mhm.
this is how the sensors collect the radiations, and depending on the radiations in the different band, we get the image, ma'am.
No, Vibham, it's very incomplete. Next, Jayashree.
Ma'am,
Yes. The direction of Vibham's answer is somewhat correct, but incomplete. Could you complete his answer?
as they use sensors, the sensor sensing completely depends upon the energy coming out from the features. And
Nobody have learned the working mechanism, is it? Sunil?
yes,
Ma'am, may I speak?
Wait a minute. Sunil,
Yes, ma'am.
can you answer
Ma'am,
this?
same answer as before.
एक बात बताओ, ग्राउंड से रेडिएशन गया, सेंसर तक पहुंचा, अब अंदर क्या प्रोसेस हुई कि आपको एक डीएन वैल्यू मिल जाएगा? क्वेश्चन सब लोग आंसर ठीक कर रहे हो कि गया, पैसिव सेंसर है, सन से आने वाली रेडिएशन को यूज कर रहा है, इट्स करेक्ट. जो भी सेंसर होगा ग्राउंड
ma'am,
से आने वाला रेडिएशन वहां तक पहुंचेगा, ठीक है, रेडिएशन पहुंच गया सेंसर तक, आगे क्या हुआ फिर?
ma'am, whenever the energy falls on energy coming out from the features falls onto the arrays, cathode ray arrays, uh, from the detectors, when due to that energy falling on the detectors, some electrons get produced inside that. Due to the flow of electrons and current developing occurs, due to that a continuous analog signal of voltage is developed depending on the proportionality to the energy and the electrons developed in that detectors. With the help due to that we'll get the voltage level. That voltage level we convert it into the dn values.
Okay, again partially correct, not completely correct. Sumit? Yes, Sumit?
Ma'am, on the basis of ma'am that since radiations, the digital numbers are assigned ma'am on the basis of voltage only. Ma'am, this was only I was about to speak that which just spoken.
Okay, Shubham? Shubham, this one is your first class? Shubham Kumar?
Yes, ma'am. Yes, ma'am.
You were not attending neither the WebGIS class nor this SIP class?
Ma'am, I wasn't there. Ma'am, I have to visit somewhere. So,
Okay. Okay.
my
Then there was one more student, Rahul Kumar. Anyone of you, please contact Rahul Kumar. He is also not attending.
Ma'am, he has left the MTech.
Okay. Okay. Coming to the question, Shubham, do you want to add something?
uh, no, ma'am, right now.
Okay. Anyone else? Anyone else want to answer it? Okay. One more question. Landsat is the along track scanner or the across track scanner? This one is very simple. Whether it is a long track or a cross track.
Ma'am, it is a long track.
It is a long track. Anyone else? Anyone else? Landsat is along track or across track?
Along track.
Along track. Again, anyone else? Read this one. What is the full form of MSS?
Multispectral.
Multispectral scan.
Multi-spectral scanner system.
Yes, multispectral scanner. So MSS are a cross-track multispectral sensor. We're searching for the other if they have mentioned, but yes, Landsat is the example of a cross-track scanner. I'm getting it right now, but yes, the answer is the Landsat, whether it is MSS, ETM, TM, OLI, they are the example of a cross-track scanners. Coming back to the question how the Landsat works, okay? See, this one is also the example, okay? So here you can see the cross-track movement. My question was how the cross-track scanners work, and listen this part very carefully because it is expected from you all to know how the scanners work. Okay, आपने already इतना पढ़ चुका है, previous semester में भी, इस semester में भी revision कर चुका है, तो working तो at least पता होनी चाहिए कि कैसे sensors work करते हैं. Starting कहाँ से होती है? First of all, radiation falls on the oscillating mirror or the scanning mirror, जो भी जहाँ जैसा यूज किया जाए. सबसे पहले जो रेडिएशन जो होता है जो ग्राउंड से आता है वो सेंसर के ऑसिलेटिंग मिरर पर फॉल होता है. उसके बाद अगला स्टेप क्या होगा आप लोग बताते जाएं किसी को अगर पता हो. Once the radiation falls on the scanning mirror, what will be the next operation or what will happen next? लाइट आ गई, व्हाइट लाइट आई है ना. अभी तो जो इनपुट हो रहा है स्कैनिंग मिरर पे जो रेडिएशन फॉल होता है वो तो व्हाइट लाइट होती है, उसमें सारे वेवलेंथ मिक्स्ड होते हैं. अगले स्टेप पे क्या होगा?
Ma'am, it will be transmitted to the CCDs.
We are talking about the cross-track scanners. I am saying it's mirror.
Prisms are also.
Yes, the next thing is filters, diffraction, gratings, or prism, whatever the scanner is using. There will be filters, there will be diffraction gratings. What is the use of that one? They will split the radiation into the segment of separate spectral bands. Okay, जो इनकमिंग व्हाइट लाइट है, अभी तो जो लाइट आ रही है अगर आप नॉर्मल देखें, जो स्कैनर पे जो ऑसिलेटिंग मिरर पे जो लाइट फॉल हो रही है वो तो व्हाइट लाइट है, उसमें अलग अलग वेवलेंथ है, लेकिन वो अलग नहीं है, वो एक है क्योंकि वो व्हाइट लाइट है. व्हाइट लाइट तो समझते ही हैं सब लोग. जब भी जैसे आप लोगों ने फिजिक्स में प्रैक्टिकल किया होगा, जब प्रिज्म पे वो पड़ती है लाइट तो क्या होता है, विबग्योर टर्म याद होगा, अलग अलग रंगों में वो डिवाइड हो जाती है, सेपरेट हो जाती है। वही चीज यहाँ बोली जा रही है कि इनकमिंग रेडिएशंस जो हैं वो सेपरेट स्पेक्ट्रल बैंड्स में आ जाते हैं, अलग अलग स्पेक्ट्रल बैंड्स में डिस्ट्रीब्यूट हो जाते हैं। उसके बाद क्या होगा, व्हाट विल बी द नेक्स्ट स्टेप? बताइए, अब क्या करें? We need to convert this one. There will be some detectors over here that will convert this energy. It will be coming in which form? They are the photons. So we need to convert these photons into the electrons. We need to convert this brightness into the electrical current. Okay. So there will be detectors with the help of which the brightness get converted into the electrical current, the photons get converted into the electrons, and thereafter with analog to digital converters, the dm value is assigned according to the electrons or according to the electric currents. क्लियर हो गया सबको? फिर से एक बार बता रहे, इसको ध्यान से सुनिएगा। या मैं बुक में, आप लोग कैंपल की बुक आप लोगों ने पढ़ी है? पढ़ी है नहीं पढ़ी है, जो भी है, कैंपल की बुक एक रिमोट सेंसिंग की बहुत अच्छी बुक मानी जाती है। इसको ये ऑनलाइन आपको अवेलेबल कहीं भी आप सर्च करेंगे मिल जाएगी। इसमें आप लोग देखिएगा, इसकी वर्किंग बहुत अच्छे से एक्सप्लेन होगी कहीं। जस्ट 1 मिनट का टाइम दीजिए, इसको मैं सर्च कर रही हूँ। लॉन्ग ट्रैक स्कैनर्स को ऑप्टिकल मैकेनिकल स्कैनर्स भी कहा जाता है। क्रॉस ट्रैक स्कैनर्स को ऑप्टिकल मैकेनिकल स्कैनर्स भी कहा जाता है। इसको मैं रीड आउट कर रही हूँ, फिर एक बार फिर से एक्सप्लेन करेंगे। ऑप्टिकल मैकेनिकल स्कैनर्स फिजिकली मूव मिरर्स और प्रिज्म टू सिस्टमैटिकली aim the field of view over the Earth's surface. The scanning mirrors scan across the field of view at right angle to the flight path of the sensor, directing radiation from the Earth's surface to a secondary optical system and eventually to detectors that generate an electrical current that varies in intensity as the land surface varies in brightness. Filters or diffraction gratings split the radiation into several segments to define separate spectral channels, so the instrument generates several signals, each carrying information about the brightness in separate region of the spectrum. The electrical current provides an electronic version of the brightness of the terrain, but it is still in analog form. It provides a continuous record of brightness observed by the sensor's optics. To create a digital version, the electrical signals must be subdivided into distinct units to create the discrete values necessary for digital analysis. This conversion from the continuously varying analog signal to the discrete values is accomplished by sampling the current at a uniform interval, a process known as analog to digital conversion. Because the values within this interval are represented as a single average, all variation within this interval is lost. The process of subdivision and averaging the continuous signal corresponding to sampling the terrain at a set spatial interval. So the choice of sampling interval establishes the spatial detail recorded by the image. Okay. So this is the whole working of क्रॉस ट्रैक स्कैनर्स। ठीक है, क्या हो रहा है, रेडिएशन, बहुत ध्यान से इसको एकदम याद कर लीजिए, बहुत कॉमन क्वेश्चन है जो इंटरव्यूज में पूछा जाता है, कहीं आप जाएंगे, इवन वाइवा में पूछा जाता है। ये तो क्वेश्चन बनेगा हर समय। हम बात कर रहे हैं कि हम लैंडसाइड डेटा को लेकर के प्रोसेस कर रहे हैं, बट लैंडसाइड डेटा खुद में कैसे डेटा एक्वायर कर रहा है, हाउ इट इज एक्वायरिंग द इमेज। क्रॉस ट्रैक स्कैनर्स का इस तरीके से, लॉन्ग ट्रैक स्कैनर्स का भी है इसमें। उनकी वर्किंग मैकेनिज्म क्या होती है, इसको ध्यान से सुनिए। सबसे पहले जैसे बताया गया, लाइट जो होती है वो ऑसिलेटिंग, जो आईएफओवी से जितना भी इनकमिंग रेडिएशन है वो जो मिरर है उसके ऊपर फॉल होता है। ठीक है, यहाँ पर मिरर जैसे आप देख सकते हो, यहाँ पर जो स्कैनिंग मिरर है उसके ऊपर ये जो ग्राउंड से आने वाला रेडिएशन है वो इसके ऊपर फॉल हो रहा है। उसके बाद में क्या होगा, ये क्योंकि कम डिवाइडेड नहीं है स्पेक्ट्रल बैंड्स में, इस कारण से इसको कहाँ पर फॉल कराया जाता है, फिल्टर्स होते हैं, डिफ्रैक्शन ग्रेटिंग्स होती हैं, ये अलग अलग सेंसर्स के अपने पूरे मैकेनिज्म होते हैं, उसको देखना पड़ता है। लेकिन फिलहाल के लिए जनरल टर्म है कि फिल्टर्स और डिफ्रैक्शन ग्रेटिंग्स होती हैं जो कि इनकमिंग रेडिएशन को अलग अलग स्पेक्ट्रल बैंड्स में डिवाइड कर देती हैं। अभी क्या फॉर्म है एनर्जी का, ये लाइट के फॉर्म में, फोटॉन्स के फॉर्म में है, ब्राइटनेस के फॉर्म में है। ठीक है, हमें क्या कन्वर्ट करने की जरूरत है, आप किस फॉर्म में देखते हो, अगर आप किसी भी पिक्सल को अभी स्क्रीन पर देखते हो, है ना, यहाँ पर अगर हम देखें तो उसका जो पिक्सल वैल्यू आ रहा है यहाँ पर, ये हमें एक सर्टेन एक हमें वैल्यू दे रहा है, डिजिटल नंबर हमको यहाँ पर प्रोवाइड किया जा रहा है। ठीक है, एक डिजिटल नंबर हमारे सामने आता है पिक्सल का, लेकिन ये अभी उस फॉर्म में तो है नहीं, ये अभी तो लाइट के फॉर्म में है। लाइट को डायरेक्ट नहीं कन्वर्ट किया जाता, सबसे पहले ये फोटॉन्स जो होते हैं उनको कन्वर्ट किया जाता है किसमें, इलेक्ट्रॉन्स में। उससे इलेक्ट्रिक सिग्नल मिलता है, उस इलेक्ट्रिक करंट को मेजर किया जाता है, जिसके बेसिस पर ए टू डी कन्वर्टर्स, एनालॉग टू डिजिटल कन्वर्टर्स होते हैं, जो फाइनली उसको एक नंबर, एक न्यूमेरिक वैल्यू असाइन करते हैं, जो हम लोग डीएन वैल्यू के फॉर्म में देखते हैं। समझ में आ गया अब ये। जब ये स्कैनिंग होती है, फिर से इस फिगर को देखते हैं, जब ये क्रॉस ट्रैक स्कैनिंग होती है, ऐसा नहीं है कि एक बार में एक लाइन स्कैन होती है, अलग अलग जो भी हम स्कैनर यूज कर रहे हैं सबके लिए अलग अलग होती है। जैसे एमएसएस होता है, मल्टी स्पेक्ट्रल स्कैनर, वो एक टाइम में कितनी लाइन से स्कैन करता है, एनीवन, एक बार में एमएसएस कितनी लाइन स्कैन करता है,
6.
यस इट्स 6। और ईटीएम, टीएम थीमेटिक मैपर, इनहांस थीमेटिक मैपर, कितनी करता है एक बार में,
Eight.
ना,
मैम 6.
6, no, 6 is not the answer. Answer is 16. Okay, answer is 16. ध्यान रखिए, for MSS there are 6, for TM, ETM plus it is 16. Okay, so at a time कोई एक लाइन नहीं स्कैन होगी, एट अ टाइम जितने हमारे पास में डिटेक्टर्स एक बार में जो होता है, या तो 16 होती है या 6 होती है, जो जैसा स्कैनर है उसके अकॉर्डिंग ये स्कैन होती है। वापस से अपने एरर पे आते हैं, विच इज लाइन ड्रॉप आउट एरर। ठीक है, आप जैसा कि यहाँ पर देख रहे हो, इस एग्जाम्पल में दिखा रहे थे, अब आप बता सकते हो कि इस तरीके की लाइन कैसे बनेगी? इतना आपने पढ़ लिया, आपको वर्किंग भी समझ आ गई क्रॉस ट्रैक स्कैनर्स की, आपको ये भी पता लग गया एक बार में। अगर जैसे ये इस केस में तो ईटीएम यूज किया गया है डेटा सेट में, सो इसमें एक बार में 16 डिटेक्टर्स लगे हुए हैं। बता सकते हैं इस लाइन के लिए? Answer is when one of the detectors stop functioning, stop working. In that case, such type of line dropout error occurs. Another thing is it is the example of systematic error. Why it is systematic? Because it will occur like for the ETM plus every 16th line will be dropped out. Okay, this is what the problem is. Every 16th line will be dropped out. It will come in a black color. So this is what the line dropout error is. This problem is specifically usually doesn't occurs because it is means generally the detectors doesn't stop working, but this one is a very big problem with the ETM plus data. Okay, such that the next error that we will learn, which is the line stripping error or band stripping error. That one is a common, but this type of error that you are visualizing right now on the screen, this one is not a common problem. Usually it doesn't happen that the detector stop functioning, but for the ETM Landsat 7 ETM plus case, this happens frequently. Okay, this happened frequently. Right now you are watching the effect that we have learned in the web GIS. Okay, maybe the screen is not synchronized. Leave it. So this is the line dropout error. You will face this error repeatedly when you work on the ETM plus data. When the satellite, when any of the sensor launched, it is ensured that all the detectors work properly. They all are very well calibrated. But sometimes over a period of time, because of some of the errors, some of the accidents, technical misfunctionalities, such type of errors took place. So this is the line dropout error. This is common with the Landsat ETM plus data. Now the next question is how to remove the error. Okay, how to remove this line dropout error. So I'm first giving you 10 minutes break. It's already late, it's 12:10. So I'm giving you 10 minutes break. And once you come back from the break, we will learn how to remove this line dropout error using three different methods by using the replacement method, averaging method, and correlation method. Okay. So 10 minutes break.
Ma'am,
Yes.
ma'am, please can you upload that book, ma'am, which you were saying to read us?
Campbell, there is just one topic. You can find it on the internet or I can upload it. No problem. I will upload that one.
Thank you, ma'am.
Let's start the class again. You have just seen the error of line dropout, where one of the line will come all zeros or all 255, something like that. In Landsat ETM plus example, you have seen that this line dropout error was coming systematically. In that case, every 16th line was blackout. Many times, what happens for a small interval, okay, just for a short interval, the detector stops working and thereafter it start working. So you can also see such type of dropout error when few of the lines, right now on the screen you can see that not all the lines are coming black, but only 1, 2, 3, 4, 5 lines are coming black. See the corresponding values 0, 0, 0, again all 0, 0, 0, all 0, 0, 0, something like that. Getting it? So this is how this line dropout error occurs. It may be systematic, as in case of ETM plus, it may not be systematic. ठीक है, दोनों केस होते हैं. एक परमानेंटली प्रॉब्लम होता है, जैसे लैंडसेट ETM प्लस का था, तो आप उसकी किसी भी साल की इमेज लीजिए, वो ज्यादातर में कुछ सालों को छोड़ करके मेजॉरिटी में ये एरर प्रेजेंट है. लेकिन कई बार ऐसा होता है कि थोड़ी देर के लिए डिटेक्टर ने काम नहीं किया, फिर वो स्टार्ट हो गया और वर्किंग शुरू हो गई. तो वाइल बीइंग के लिए जब रुकता है तो आपको इस तरीके की कुछ एरर दिखाई देगी कि फ्यू लाइंस ब्लैकआउट हो गई या वाइट हो गई. नेक्स्ट, इसको रिमूव कैसे किया जाए? स्पेशल ऑटो कोरिलेशन याद है क्या होता है? ओके, शिवम. शिवम, am I audible?
Yes, ma'am.
Okay. So Shivam, I don't think so he's here. Okay, Prameed.
Yes, ma'am.
What is spatial autocorrelation?
Hello.
Yes, Prameed.
Yes, ma'am.
What is a spatial autocorrelation? नाम सुना है इसका, स्पेशल ऑटो कोरिलेशन का आपने?
Yes, ma'am.
कहाँ पे पढ़ा है?
GIS में मैम.
GIS में तो पढ़ा ही, तभी तो हम पूछ रहे हैं. GIS में किस टॉपिक में पढ़ा है? प्रवीण, आंसर आता है?
नो मैम.
मेहनत करिए प्रवीण, GIS देखिए, बहुत बेसिक क्वेश्चन है. नेक्स्ट, पारुल.
Yes, ma'am. Ma'am, in autocorrelation, spatial autocorrelation, we observe the similar or correlated variable between, ma'am, nearby observation को measure करते हैं based on the similarity.
Again, Parul, you are not answering it appropriately. Okay. So the answer is, we have learned about the Tobler's law of geography.
Hello, ma'am.
Yes, Praveen.
मैम स्पेशल ऑटो कोरिलेशन में मैम होता है जैसे कि मतलब मैम किसी एक स्पेसिफिक एरिया का मतलब हाइट में जैसे मालूम होती है, तो मैं उसके मतलब एक विद इन कुछ एरिया में अगर हम जैसे किसी की मतलब कुछ मेजर करते हैं, तो मैम जैसे उसकी हाइट या मतलब डिस्टेंस वगैरह, तो मतलब एक स्पेसिफिक रीजन में मतलब वो ही हाइट वगैरह देखते हैं. आई थिंक ऐसे ही कुछ था.
ऐसे नहीं आंसर किया जाता, ठीक है. आंसर ऐसे किया जाता है कि अब हमको आंसर करने दीजिए कि कौन है, नाम बताइए।
मैम, I'm Jayashree.
Yes, Jayashree.
Ma'am, in the concept of spatial autocorrelation, we can say that near things are more related than the farer things, but everything is related to all. That means everything is related to everything else, but more we concentrate on the near things.
Yes. So, as per Tobler's law of geography, as Jayashree stated, that everything is related to everything else, but nearby things are more related than the distant one. According to this definition, or according to this Tobler's law, there is a property called autocorrelation that holds with the spatial data. In case of spatial data, we can say whatever things that we are measuring, whatever properties we are measuring, the nearby things will have the similar values as compared to the distant one. So whether we are taking elevation, whether we are taking temperature, whether we are taking rainfall, in all these cases, the nearby measurements will be similar. This is what the spatial autocorrelation property was that we have learned in the GIS. This is many times useful, many times it creates problem, like when we are doing the interpolation. If the data set is independent, there is no relation. In that case, you cannot do the interpolation. It will not give you the value, correct value, because things are not related. They are independent to each other. How can we say? But since the spatial data holds the autocorrelation property, that's why it is possible to perform the interpolation over there. Whenever we are getting a continuous data, like in the raster form, we are getting a continuous data. Whatever data we are taking, elevation, temperature, pressure, rainfall, we are getting a continuous data, but they are not collected at all the places. How we are giving a continuous surface, it is based on the interpolation, which is done on the basis of this autocorrelation property. But sometimes it creates problems also, where when the condition is random, when we do the statistical analysis, many times the condition is that we are taking a random samples over there. But in GIS, the samples are not random because of autocorrelation property. So there are different coefficients that you may remember: Moron's I coefficient, Guéret, Moron's I coefficient, Guéret's C coefficient. These were there to measure the correlation property. Okay. So this is how you need to answer when somebody asks what is correlation, spatial autocorrelation. Now coming back over here, why autocorrelation I am discussing right now? Because in this case, when such type of dropout occurs, the nearby values are taken. Okay, nearby values are taken, and on the basis of that value, we can remove the blackouts. Now, in very first method, there is a replacement method. As I have explained about the autocorrelation property, because of this property, the blackout line is replaced by immediately above or immediately bottom line. Okay, means previous line or succeeding line. ठीक है, एक पहले या एक बाद की लाइन से करंट लाइन को रिप्लेस कर दिया जाता है, वही वैल्यू उसमें डाल दी जाती है. ओके, तो इस तरीके के मेथड हमारा पहला मेथड है कि जिसमें मिसिंग वैल्यूज जो होती हैं उनका पिक्सल उसकी अगली लाइन का, जैसे यहाँ पर देखिए DNIJ विल बी इक्वल टू DNIJ-1. तो यहाँ पर JI-1 क्या है? प्रीवियस रो, पहले वाली रो है, तो उससे इस वैल्यू को रिप्लेस कर दिया जा रहा है. तो अगर कहीं पर वैल्यू हमारी नहीं आ रही है, जैसे कि इस केस में यहाँ कुछ पोजीशंस पर वैल्यूज मेजर नहीं हो पा रही हैं, तो उसमें हम क्या करते हैं, यहाँ पर हम वैल्यूज को रिप्लेस कर देते हैं. यहाँ पर जो वैल्यूज होती हैं इन पोजीशंस पे इमीडिएटली अबव और इमीडिएटली बिलो से हम रिप्लेस कर देते हैं. ठीक, ये पहला मेथड हो गया. सेकेंड मेथड इज एवरेजिंग मेथड. व्हाट इज एवरेजिंग मेथड? In this case, instead of taking entirely previous or succeeding line, we take the average of previous and succeeding line. Okay. So in this, the missing pixel value is replaced by the average of the corresponding pixels on the scan lines above and below the defective line. ठीक है. So यहाँ पर ऊपर और नीचे की लाइन को लेकर के एवरेज लेकर के वैल्यू को रिप्लेस कर देते हैं. प्रॉब्लम कब आएगी इस मेथड में? इस मेथड में प्रॉब्लम कब आएगी, या ये मेथड क्यों बहुत अच्छा नहीं माना जाता?
मैम सपोज देर आर 2 pixels जिसमें डार्क मीन्स वेरी ग्रे स्केल इज देयर, and in between them there used to be a bright scale, but we were not having that information. Therefore if when we use averaging, it will give the average value of those gray scales, but it will not give the actual values.
Okay. ये स्क्रीन थोड़ा सा ब्लर हो जा रहा है यहाँ पर इतना जूम करने पर, बट यहाँ सपोज करिए क्या हो रहा है, इस लाइन के इस पोजीशन को देखे जहां पर हमने अपना कर्सर प्लेस किया हुआ है अभी, इसके जस्ट अबव पे एक व्हाइट कलर की लाइन पिक्सल होगा और उसके जस्ट नीचे एक पिंक कलर का पिक्सल दिखाई दे रहा है. मींस ऊपर वाले में बहुत हाई ब्राइटनेस वाली प्रोबेबली वहां पर सैंड होगा और उसके नीचे वेजिटेशन है. ठीक, तो यहाँ दोनों में क्या हो रहा है, वैल्यूज में बहुत अंतर है. अगर हम सिंपल रिप्लेसमेंट कर देंगे तो वहां पर या तो सैंड आ जाएगा या वेजिटेशन आ जाएगा, कोई एक एग्जिस्टिंग वैल्यू से वो रिप्लेस हो जाएगा. बट सपोज एवरेज आउट किया, सैंड की वैल्यू नियर अबाउट 200, वेजिटेशन की वैल्यू नियर अबाउट 100. ठीक है, 200 और 100 का एवरेज ले लिया, 150 वैल्यू आ गई. अब ये 150 ना तो सैंड को बिलोंग करेगा, ना तो वेजिटेशन को बिलोंग करेगा, ना तो वाटर को बिलोंग करेगा. ये एक हाइब्रिड पिक्सल बन जाएगा. ये प्रॉब्लम आती है जब आप एवरेजिंग टेक्निक को यूज करते हैं. ये एक्सप्लेनेशन सब लोग बहुत ध्यान से याद कर लीजिए, हाइब्रिड पिक्सल प्रॉब्लम, क्योंकि आप जब कभी भी अभी आगे के टर्म्स में जब हम लोग रीसैम्पलिंग पढ़ेंगे, ज्योमेट्रिक करेक्शन पढ़ेंगे, वहां रीसैम्पलिंग आएगा. या रीसैम्पलिंग हम लोग ऑलरेडी पढ़ भी चुके हैं प्रीवियस सेमेस्टर में जब जियो रेफरेंसिंग करा था. नियरेस्ट नेबर, बाइलिनियर इंटरपोलेशन एंड क्यूबिक कॉन्वोल्यूशन, ये 3 मेथड्स वहां देखे थे. रीसैम्पलिंग वहां पर प्रिफर क्यों किया गया था? बिकॉज वो एग्जिस्टिंग वैल्यू को लिया जा रहा है, ना कि एग्जिस्टिंग 4 या 16 वैल्यूज को लेकर के एवरेज आउट किया जा रहा है. वहां पे भी सेम यही हाइब्रिड की प्रॉब्लम थी. यहाँ पे भी सेम वही प्रॉब्लम बताई जा रही है कि आप जब कभी भी एवरेजिंग को यूज करेंगे, एग्जिस्टिंग वैल्यूज में एवरेज करेंगे, तो निकलने वाला पिक्सल ज्यादा भी हो सकता है, कम भी हो सकता है. ये नॉन एग्जिस्टिंग क्लास को रिप्रेजेंट करने लग जाएगा. फ्यूचर में जाकर के अगर इस इमेज का क्लासिफिकेशन होगा और तब 150 की वैल्यू आ जाएगी, इन दैट केस 150 को कौन से क्लास में रखा जाएगा, वहां पर ये प्रॉब्लम आती है. इसीलिए हमेशा हम लोग अवॉइड करते हैं कि अगर डेटा में वेरिएबिलिटी है, जैसे इस पर्टिकुलर इमेज सीन को अगर आप देखें, इस इमेज सीन में सारी चीजें प्रेजेंट है, वाटर भी है, सैंड भी है, लैंड भी है, वेजिटेशन भी है, सब प्रेजेंट है. अगर वेरिएबिलिटी डेटा सेट में है, लैंड यूज लैंड कवर में है, उस केस में इस तरीके का अगर कोई लाइन आ रही है और बाउंड्री पोजीशन पे उसका कोई भी पॉइंट फॉल हो रहा है, सैंड और वेजिटेशन के बीच का कोई पॉइंट आ जा रहा है, इस तरीके के केसेस में हमको ये चीजें अवॉइड करनी चाहिए. बिकॉज एवरेज आउट करने के बाद में जो पिक्सल बनेगा उसकी डीएम वैल्यू एग्जिस्टिंग क्लास में किसी की भी नहीं होगी. ना तो वो 200 डीएम वैल्यूज वाले सैंड को रिप्रेजेंट करेगा, ना वो 100 वैल्यूज के अराउंड की वेजिटेशन को रिप्रेजेंट करेगा. 150 बिकम हाइब्रिड, उसका कोई भी क्लास नहीं होगा, जो लेटर ऑन जब आप क्लासिफिकेशन का प्रोसेस कंटिन्यू करते हैं, इन दैट केस वो 150 वैल्यू एक प्रॉब्लम देगा. उसको कौन से क्लास में डाला जाए, ये एक इश्यू जनरेट होता है. सो दैट्स व्हाई एवरेजिंग टेक्निक अच्छी है, लेकिन अगर इस तरीके का बाउंड्री सिचुएशन है, उस केस में इसको अवॉइड किया जाता है. नेक्स्ट, मेथड 3. ओके, मेथड 3 एक इंटरेस्टिंग मेथड है. इसमें अभी आपने जो पढ़ा को रिलेशन को वेरिएंस, वहां पर उसको यूज किया जाता है। इस मेथड में जो एग्जिस्टिंग दूसरे बैंड होते हैं, ऐसे बैंड जो हाईली, क्योंकि सारे बैंड में ये एरर है ये कोई जरूरी नहीं है, तो हाईली कोरिलेटेड अगर बैंड है कोई, उसकी वैल्यू से रिप्लेस कराया जाता है इस थर्ड मेथड में। तो ये भी सेम पोजीशन पे सेम लाइन के लिए किसी दूसरे हाई कोरिलेटेड बैंड में क्या वैल्यू है उसको प्रॉपर मैथमेटिकल कोरिलेशन डिफाइन किया जाता है एंड देयर आफ्टर उससे रिप्लेस कराया जाता है। तो ये 3 डिफरेंट मेथड्स होते हैं जिनके थ्रू हम लोग मिसिंग स्कैन लाइन को रिमूव करते हैं। ध्यान रखें, मिसिंग स्कैन लाइन रिमूवल कंप्लीटली ऑटोमेटिक प्रोसेस नहीं है, ये सेमी ऑटोमेटिक प्रोसेस है जिसमें हमें लाइन नंबर देना पड़ता है। मतलब ठीक है, इस तरीके का यहाँ पर एरर है। अगर आपको रिमूव करना है, सबसे पहले आपको इसमें आने वाली कौन कौन सी पोजीशन पे ये एरर है प्रेजेंट, ठीक है, कौन कौन से पोजीशन पे ये एरर प्रेजेंट है इसको निकालना पड़ता है। सपोज हमने कर्सर यहाँ पर अपना प्लेस किया, बताइए कौन सी लाइन पर ये एरर आ रहा है, what is the line number, what is the number of line at which line number the line dropout error is taking place। आंसर आपके सामने है, सामने व्यूअर 4 जो खुला हुआ है उसी में आंसर है। what is the line number at which the line dropout error is taking place।
मैम एक्स एंड वाई।
लाइन नंबर क्या है, सही डायरेक्शन में जा रही हैं आप, लाइन नंबर बताइए।
वन थ्री वन एट।
1318
मैम
मैम -156.346283।
इसको और सही करिए, सही बता रहे हैं, सही से बताइए। The answer is line number 156। ओके, हम यहाँ पर y से जो रो होता है, रो नंबर, वो y से वैल्यू हमें मिलेगी। इसको थोड़ा सोचिए, x एंड y में, x एंड y जो है पोजीशन बता रहा है, सो y विल गिव यू द पोजीशन ऑफ रो। तो यहाँ पोजीशन क्या आ रही है, -156 पॉइंट समथिंग। सो हम जब लाइन नंबर एंटर करेंगे इट विल बी 156। देखिए यहाँ पर रिप्लेस बैड लाइन का यहाँ पर आ रहा है, इनपुट बैड लाइन। ओके, ओके, देखिए replace bad, there can be a line, there can be column, in our case it is line, then technique, average, copy line above, copy line below। ठीक है, आप इनमें से कोई भी एक ले लीजिए। enter the bad line number, हमने क्या बोला, it's 156 और 158 मिनट। 156. ठीक है, देन नेक्स्ट वन, इसमें लाइन नंबर क्या होगा?
186.
Yes, it will be 186. And then 198, 190, 198, 186, 198. लास्ट वन इज 210. वैल्यूज थोड़ी सी आगे पीछे हो सकती हैं. चलिए देखते हैं आंसर. ओके, इट्स डन. Corrected bad line. देख रहे हैं, करेक्टेड बैड लाइन में ये सारी जो एरर थी यहाँ पर 4 लाइन की जो एरर थी यहाँ पर आउटपुट में देखिए वो रिमूव हो गई पूरी. So I hope this.
मैम सेम प्लेस पे 186 187 दोनों लाइन शो कर रहा था, तो आपने पर्टिकुलरली एक कैसे चूज किया?
यहाँ पर देखना पड़ता है कि वैल्यूज कहाँ से जा रही है. ठीक है, यहाँ पर देखिए आपको 186 का ही यहाँ पर रेंज दिख रहा है. ऊपर जाकर के ये 187, यहाँ पे भी 185 यहाँ पर रह रहा है. मतलब जहां लाइन नहीं है, इसको देखिए, देख रहे हैं? देखिए,
यस मैम.
इसको यहाँ से देखना शुरू करिए. यहाँ से समझाइए. देखिए यहाँ पर दूसरा पिक्सल चल रहा है. ठीक है, जहां पर अभी मेरा कर्सर प्लेस्ड है यहाँ पर वैल्यू 185 है, लेकिन अभी हम व्हाइट पर नहीं आए हैं, ये अभी ग्रे वाले पे ही चल रहा है. जैसे ही हम व्हाइट पर आते हैं, इसको देखिए अभी भी 185 चल रहा है, लेकिन प्रीवियस में भी 185 था. तो प्रीवियस का वैल्यू 185 हम मान ले रहे हैं और इसको 186 मान रहे हैं. ये पूरा ये कंप्लीट एक पिक्सल है ब्लैक व्हाइट वाला. ठीक है, तो यहाँ 185 पार्शियली आ रहा है, इट्स ट्रू, लेकिन आप देखिए 185 जो है वो पहले ऑलरेडी था प्रीवियस वाले पिक्सल में. इसी तरीके से आप जब अगले में भी जाएंगे तो यहाँ देखिए अभी भी 186 दिखा रहा है, लेकिन 186 ऑलरेडी पहले स्टार्ट हो चुका था. तो इससे हमको एक आइडिया मिल गया कि यहाँ पर वैल्यू 186 रहेगी. So this is all about line dropout or missing line error. This is semi-automatic procedure to remove the error. The error could be removed by replacing the current line by either previous line, by either next line, or by the average of above and below line, or by another band, by another highly correlated band. Okay. So these are the different ways through which we can remove the line dropout error. Line dropout error is common in ETM plus Landsat, ETM plus dataset. In that one, every 16th line was dropped out. But in general, line dropout error or missing line error is not frequently occurring error. Sometimes when the detector stops working for a while, just for a while, for a short interval, only in that case some of the line will occur as a line dropout error. Now coming to the next one. Before explaining what is line stripping error, I will show you the images and you by yourself need to understand what is the difference between the wait a minute. Okay, the left hand side is showing the stripping error, line stripping error, and the right side is the bad line or line dropout error. Now, could you tell what is happening in line stripping error?
Ma'am, in line stripping error, there at a particular interval, the error is being replicated. It is being repeated again and again. This could be like systematic error.
Yes. Anything else? Okay. Line stripping error is much more common than the line dropout error. First, we need to know how this happens. As you know, like again, I will take the example of Landsat. Like in Landsat TM or ETM plus, there are 16 detectors. Okay, at a time, 16 lines get scanned together. When the sensor is launched, all the detectors are well calibrated. So their response will be identical for same values. For the same land use land cover, their response will be identical. For incoming radiation, the output DN value should be identical. This one is the ideal case. जो अगर एक जैसा input radiation है, इनपुट अगर सेम है तो आउटपुट डीएन वैल्यूज जो उस डिटेक्टर से मिल रही है वो आइडेंटिकल होनी चाहिए, सेम होनी चाहिए. ये आइडियल केस है. होता क्या है, ओवर द टाइम जब ये वर्क करते जाते हैं सेंसर, ओवर द टाइम इनका कैलिब्रेशन जो होता है वो बिगड़ जाता है. जो आइडेंटिकल नेचर की बात यहाँ पर करी जा रही है वो ना रह करके कुछ में थोड़ा सा वैल्यू ज्यादा आने लगता है सेम इनपुट पर, कुछ में सेम इनपुट पे थोड़ा सा वैल्यू कम आने लगता है. इसके कारण से ये लाइन स्ट्रिपिंग एरर होती है. ये बहुत कॉमन एरर है, स्पेशली लैंडसेट एमएसएस और टीएम में ये डेटा आता था. अगेन ये सिस्टमैटिक एरर है. ड्रॉप आउट सिस्टमैटिक नहीं भी हो सकती, कोई जरूरी नहीं है, लेकिन ETM प्लस के केस में वो सिस्टमैटिकली अकर हो रही थी. बट इन जनरल ऐसा नहीं होता कि लाइन ड्रॉप आउट एरर्स हो, बट लाइन स्ट्रिपिंग एरर एक फ्रिक्वेंटली अकरिंग एरर है और ये अगेन एक सिस्टमैटिक एरर है, क्योंकि जिस भी डिटेक्टर में प्रॉब्लम आ रही है, जैसे इस केस में आप स्क्रीन पर देख रहे होंगे कुछ वैल्यूज ज्यादा आ रही हैं. ठीक है, अगर इसको हम जूम इन करके दिखाएंगे, देखिए एक सर्टेन इंटरवल पर आप देख रहे हैं कि पिक्सल वैल्यूज ज्यादा दिखाई दे रही हैं. इसका एक और एग्जांपल दिखाते हैं. इन दोनों इमेजेस को, लेफ्ट एंड राइट इमेज को कंपेयर करिए, स्पेशली यहाँ बॉटम राइट में. You can see this error very clearly at this portion. Okay, on the right hand side you can see that this portion is smooth, and on the left hand side you can see some lines. Some lines are appearing over here. Throughout the image you can find this thing out, that some sort of lines, horizontal lines are appearing on the image. Whereas on the right hand side image it is comparatively smooth. This is called the line stripping error, and it depends upon the sensor detectors. So for the MSS, the sixth line stripping error, there will be 6 line stripping. In case of ETM plus or TM, every 16th line will give you such problem. Now, if we compare this one with the line dropout error, whatever data is present in these lines, in these strip lines, the data may not be correct, but they are not absolutely correct. Like in case of dropout, it was 0 or 255. So nothing has been observed in that case. But in such type of horizontal banding pattern, whatever data is present, it is showing incorrect brightness value, but it is near to the correct values. So that's why in this case, we do not completely replace the given lines by the existing one. Instead of that, what we do, we try to resolve this problem by using two methods. One method is called linear method or global linear detector matching method. Second one is the histogram matching method. The concentration will be on first method, which is the linear method. Now, what is linear method? Linear method is again, as the name of this method says, linear. So a linear expression is used to model the relationship between the input and output value. That's why it is called a linear method. This method is based upon an assumption. What is the assumption? The assumption is that the histogram generated from the pixel values produced by n number of detectors, like in this case it is 16 for TM, 16 for ETM plus 6 for MSS. So if there are n detectors, the histogram which is generated from the pixel values produced by these detectors should be identical. So what does this implies? What does the identical histogram implies? We have learned it in the previous term. Identical histograms.
Same feature will be there.
Identical histogram means that the mean and the standard deviation will be same. Okay. So in case of linear method, it is assumed that the histogram which is produced by n number of detectors, they will be identical. Their means and the standard deviation will be same. All the data set which is produced by the different detectors, their mean and their standard deviation will be same. The only reason of mismatch will be detector imbalance that we are studying right now. Because of this only, there will be a mismatch in the values. So for this purpose, we use the linear method. Now see how the linear method works. You need to note it down because you will going to do a numerical on this one. Write it down. First of all, mean and the standard deviation of each detector will be computed. Write this thing in your copy. Step 1, calculate the mean and standard deviation for each detector. Second, calculate mean and standard deviation of full data set. You already know how to compute the mean and standard deviation of each detector. Second thing is, first you will do the computation of mean and standard deviation for each detector. Thereafter, you will do the same thing for the whole data set. So you can compute it by using the existing formula that you have learned, or you can use this formula which is given on the screen. It is a short method. Standard deviation is equal to summation of Ni. Ni is the number of pixel in that band. Basically, write it down as on the sigma, write it down I from 1 to m. ठीक है, जहां से जहां तक वेरी कर रहा है वैल्यू डिपेंड करेगा, 1 to 6 हो सकता है, 1 to 16 हो सकता है, जो भी होगा. Summation of I from 1 to m, Ni, then म्यू इज द मीन, उस बैंड का जो मीन है म्यू आई स्क्वायर प्लस सिग्मा आई, उस बैंड का जो स्टैंडर्ड डेविएशन है उसका स्क्वायर डिवाइडेड बाय summation of ni, which is total number of values or total number of pixels, minus mu square means overall mean value. फॉर्मूला को लिख लीजिए, जब आप इस पे न्यूमेरिकल करेंगे तब आपको क्लियर हो जाएगा ये. Next step is compute bias and offset. So bias is the multiplying factor, offset is the addition constant. Okay. So write down the formula of bias which is given over here. Overall standard deviation divided by standard deviation of that band, and offset is equal to overall average minus bias into average of that band. The output from a detector is a linear function of the input value according to the expression output pixel value equal to offset plus gain into input pixel value. So this is the overall process of computing the line de-stripping values. Okay. By using these formulas, we can perform the line de-stripping. In the next turn, we will do the numerical on this one. So I hope all of you have written down the formulas which are shown on the screen. This is the whole process of doing the de-stripping by using the linear method. In the next turn, when you apply this one on the numerical, then it will get more clear. So this is how we will perform the line de-stripping. The error is called line stripping and the removal of that one is called line de-stripping. Okay. So these are the two cosmetic errors that we have discussed today. First one was the line dropout. Second one is the line stripping. There is one more, random noise. Okay. So we will, in the next turn, we will see the numerical, we will see the random noise, and thereafter we will go to the geometric errors. So that's it from my side for today. Tomorrow's WebGIS class is cancelled because in the institute, as per the institute notice, there will be no classes for tomorrow as the convocation, 18th convocation is going on tomorrow. So therefore, there will be no classes. There will be no class of WebGIS tomorrow from 11 to 1 slot. Okay. So any question from your side? Okay, then thank you so much. The class is over for now.
Thank you.